blank. Okay, so guys, today we're going to go ahead and do 3, 4. We're going to talk more about those zeros of those polynomials, but I'm going to give you some other tools that you need to use. Let me see if I can figure out how to get back to my visualizer. Okay, so there we are. So today we're going to also use the Desmos. So you might want to have that one out and open because we're going to talk a little bit about graphing polynomials. And we learned before, while you're getting those out, that if they were an odd degree, okay, so remember, if the highest power happened to be x to the third, x to the fifth, x to the seventh, okay, anything odd, and we looked at the leading coefficient of that x to the whatever the degree was, then the end behavior was the opposite. So what had happened was, as x is going to go really big, y, if it's the leading coefficient was positive, then y was going to get really big. If x is going to be really small, then y was going to be really small. So it was the opposite of each other. If we found out that if the leading coefficient was negative, though, it flipped. So was x got really big, y got really small, and when x got really small, y got really big. Okay. What happened with even powers? Like if you had x squared, x to the fourth, x to the sixth, what does the end behavior kind of look like? What did you learn?
It falls up and it rises up. Like they go up.
Right. It looks kind of like what I would almost think of, maybe like a weird written W, or maybe and that's if the leading coefficient was positive. But if it's negative, that means the leading coefficient would look like kind of a weird M. So you're right. But if you imagine way back when, let's say like before we had the advantage of having like Desmos. We had all of these mathematicians sitting around trying to plug in all of these numbers. And we learned that synthetic division helped us quite a bit, because when we found, like if we wanted to know what f of 2 was, we could use the synthetic division for that polynomial, and that also worked. That we could find that would give us the y value at that particular point. But today we're going to also look at the zeros. Now remember, zeros are going to be where they cross the x-axis. Okay, so again, just what we had before, if it crosses the x-axis, then it would be considered a zero. And so we have possible rational zeros that we're going to talk about. Remember, rational could be a square root number. I mean, just as long as it has a value. If it had an imaginary number, they can still consider it a root, because like on this one, if I have an x to the third that maybe goes up and then it comes back down and it looks a little bit like this, I know that I have a root right here. So odd, odd degrees will have at least one root, okay? It may be like the square root of 2 or something like that. It might be a decimal, but it's going to be a root. But notice, like on this one, it's not going to have a root here that's going to be, it would be an imaginary root because it doesn't cross the x-axis. Now I could have them, we've had several where you're going to have 3 roots. But remember, when you have like an x to the fifth, or like an x to the third, you're going to only have at most 3 different roots, okay? And so what we did is they found that there was a way that we could eliminate a lot of different possibilities from infinity. And so if I look at the rational root theorem, what it states is that if you have a polynomial, and so this is just a way we can write a polynomial starting with x to the n, and x to the n is just going to be, it could be an even, it could be an odd, and it goes all the way down until you have an integer. Then the possible rational roots can also be found by p divided by q. And so what you want to do is, if you notice that p is going to be then the last term, in this case it's going to be the 12. And q is also going to be then the leading coefficient. So p equals the constant, okay? And that's just going to be the number that has no variable with it, okay? So it's always going to be the very end of our variable, or the end of the if it's written in the right order, it'll be the very end. It will also not have a variable with it. So we know it's not 11, we know it's not 2. Does that make sense? Q is always going to be the leading, I'll write it out today, ing coefficient. Okay, so the leading coefficient in this case is going to be 1 because I have 1x to the third. And so when I find all the possibilities of the rational roots, then I'm going to find it by saying I want to go the factors of p divided by the factors of q. And so when I look at the factors of, again, I'm going to go the factors of 12 divided by the factors of 1 in this case. So like 12, I know that 12, 1 and 12 also are going to be a factor. If I keep going up, and what I tend to do to find all my factors is I just jump it up. So if I start with 1, I always know I have 1 in the number. But then if it's an even number, I'm going to have 2 and a number. So 2 times 6 is going to be 12. Then I'm going to go ahead and go on to 3, and 3 times 4 is going to be 12. And then I know I can quit because the next one is going to be 5. 5 doesn't go into it. And then I start repeating with 4. So I know I've got them all. So I'm going to have all of the factors of 12 divided by all the factors of 1. That's also just going to be, in this case, 1 in itself. Now, all of these factors also could be a plus or a minus. So what we're going to do is we're going to list all of those possible rational roots, so plus and minus, plus and minus, plus and minus on all of these. So in this case, I just have to go over 1, so I know that I have, if I list the factors of 12, I've gotten all of the possible rational roots. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12 would be all of those possible rational roots. Now, with since I have Desmos, and I went ahead and plotted the same polynomial right up here, notice that if I look at my roots, I have roots of 3, 1, and 4. And notice that they're all in my list of possible rational roots. And so what's nice is that by knowing at least one of them, then you can usually get all of the rest, okay? Or it helps to get the rest. So the next one, we have a different equation. So let's look at let's first identify what P is and what Q is. So P is going to equal what? I shouldn't say it. So P, what is my constant? 4, okay? And then I'm going to have Q, which is going to be 2. Now, that means I'm not just going to use 4 and 2, I'm going to use all of their factors, okay? So what are the factors of 4? And the factors of Q would be then? Now, when I write then P over, goodness, I wrote Q. When I write then P divided by Q, and I want to go, what are my possible rational roots? Then I'm going to start off and I just have to make all of those different combinations. And so in your book, it's kind of a pain, I think, to write. That's why I don't have you on your homework assignments, I don't have you write too many because you can get a pretty long list depending on if you have your factors. And you can write them in any order. And I've checked that with your homework. You can write them in any order too and still get the right answer. But what I tend to do is I start with my first one and I just go ahead and make sure I have all the combinations underneath it. So I have plus or minus 1 over 1, and then I have plus or minus 1 over 2. Then I go to 2, and I'm going to go plus or minus 2 over 1, which is just 2. And then I have plus or minus 2 over 2, but 2 over 2 is just 1. Right, and so it's already written right here. Then I'm going to go to 4, so I have plus or minus 4 over 1. And then I also have plus or minus 4 over 2, and 4 over 2 is just going to be 2. So that would be then my my list of possible rational roots. And by I went ahead and put this one in also for Desmos. And so I'm going to look and notice that I do have a couple of those. And what we're going to do is we're going to find what they are. Notice that if I have a number that looks like negative 1.23607, that's actually not one of my possible rational roots. It's going to be one that's going to be uh, like a radical, okay? But notice I have the 1/2, and 1/2 was also part of my possible rational roots. We're going to come back to this one in just a second because we're gonna find all of the zeros that we have. So we're gonna practice just finding all the zeros using our synthetic division. And then I think I have this one also that we have listed that we're gonna do the division test, and we're gonna find all of the rational roots. So we're gonna come up and find this negative 1.2367 and the 3.67 in just a second. So on the next page, as I flipped over, it says use synthetic division to find the possible rational roots and then find an actual zero on the polynomial function. So remember on this one that we had before, this was all the possibilities, but we used Desmos to kind of cheat or look to see if that would make sense. So I knew that from my first equation that I had is this the one? 1 is going to be a 4 and then also -3. So what we're going to do is, and on your test, just to kind of give you a heads up on this, what I do just to kind of help save some time is I will say, and one of your roots is, and I give you one of them, okay? So we kind of just did that. And so you guys pick 1, 4, -3. Which would you like to try? 1. Let's just do 1. So if we know that 1 is going to be a rational root, because we actually cheated with Desmos, or not cheated, but we're going to list our synthetic division. It's already written in descending order. So I'm going to go ahead and write 1, -2. I'm going to have -11 and then 12. Now remember, when I do synthetic division, and it's a 0, what is the last digit going to be? From our remainder theorem, remember this number right here better be 0 because the y value, that's what the remainder theorem that we did on Friday said should be. Okay, but let's just check. Remember, we're going to drop the 1 down. We're going to put a 1, and we're going to go 1 times 1, which is going to be 1, right? And then -1 times, or -2 plus 1 is going to be -1. Then I have -1 times a -1 times -1 is going to be a -1. Goodness, I'm jumping ahead. I've got to hurry. Okay, so I'm going to have a -1 here. -11 minus 1 is going to be a -12 times 1 is going to be a -12. And lo and behold, it is 0. Now, what we have then is a reduced polynomial. Since we start with x to the third, that means this is going to be now x squared. So I have x squared. Then I can rewrite it as minus x or 1x and then -12. And that's my reduced polynomial from this. Now, I can now go ahead and use my synthetic division again, or I could just factor. And this one's kind of easy to factor. So I have factors of 12 that subtract to give me -1. Do you guys know what they are? Yes, so x minus 4 and then x plus 3. And that correlates there too, because I said from my first one, I had a solution. My solutions are my zeros. Let's go ahead and call it ZEROS, would be then the one that we started with from my synthetic division. But then I'm also going to have then 4 and also -3. Okay, just to make sure you also know, I could also factor this. And so remember for my first one, that would mean that I have factors of x minus 1 times x minus 4 times x plus 3. That would also be, whoops, that my 0 on the other. So in other words, this is my factor form. that gave us those zeros. Okay, and again, Desmos is also a great way to check that because then I can look and say, where are my zeros? And I could find all of my zeros are going to be those same ones that I came up with. What you have is that I'm going to give you a degree 3. Okay, so one, it'll have all your zeros, but then it's also going to have, I'm going to also say you will have a 0. Like, in other words, I'm going to give you like x equals, or and in parentheses, 1 0 is 4, or 1 0 is -3, or 1 0 is 1. And then you use synthetic division to find your reduced polynomial. And then after you've got it in a quadratic, then you can either use your quadratic formula, which we're going to do in the next one, or you can just factor. If it factors, then you know you had 3 different numbers that were just whole numbers. But sometimes we're going to also have then imaginary. Okay, so let's do this next one. So this is the same one we had before. Oh, okay, so let me try and go there. So this is going to be the same one that we had before. And so let me go ahead and just highlight it instead. And so I've got this one, and so I know that I've got some roots. I've got one here, I've got a 0.5, and I've got this one right here, the 3.2607. Both of those are indicating it's probably going to be a square root. So I wouldn't use that in my synthetic division because you're not going to come up with 0. It's going to be just really, really close because remember, I can take the square root of a number and this is an approximate value, but it's not the exact value. So I want to use the 0.5. This is the one that I know that I want to use in my synthetic division. So I'm going to have 1/2. Let me go ahead and pull up my camera. So I've got 1/2 in my synthetic division. Then I'm going to go ahead and write all of my numbers. So I have 2, I have a -5, I'm going to have -6, and I'm going to have 4. So I'm going to start off, I'm just going to drop my 2 down. So 2 is going to go there. 2 times 1/2 is 1. So then I have -5 plus 1 is going to be -4. -4 times 1/2. Perfect. So that means that I have a reduced polynomial of then 2x squared minus 4x minus 8. Now, I can do a lot of things with that. I could pull out a 2 if I wanted and divide everything by 2. You could do that. Or you could go ahead and just use your, I could see if it factors. So let's go ahead and divide everything by 2. I have x squared minus 2x minus 4 is equal to 0. I kind of know from my Desmos that I'm not going to have a whole number, but I could look to say, well, factors of 4 that subtract to give me 2, and I can't come up with anything. Okay, so that means I've got to use my quadratic. So I'm going to go start with a minus b. So I have a minus 2 plus or minus the square root of, and I'm going to have b squared, which is going to be then -2 squared minus 4 times a, which is going to be 1, times c, which is going to be a -4. Now, when I have the -4 here, I automatically change both of these to positive, so remember I'm going to add. Divided by then 2 times 2. So I'm going to grab my calculator and I'm going to kind of simplify it a little bit with a radical. So I end up with 4 plus 16. So I'm going to end up with 2 plus or minus the square root of 4 plus 16, 20 all over 4. And then I'm going to know that the square root of 20 simplifies to 2 square root of 5. If you, 2 times 2, 2a, A in this case. Oh, I did change it to 2. Oh, you know what, on my notes, you were correct. It's going to be just 2 because I looked up here at this 2 and you were correct. I plugged back. I think I jumped them. Holy cow. I did a combination, which is definitely wrong. So let me try again. Let me just cover this one up. So I'm going to go a -2 minus a -2 plus or minus the square root of b squared, which is going to be -2 squared minus 4 times 1 times a -4 all over 2 times a, which is going to be then 1. I guess I only messed up that 1. I kind of looked up at my first equation right here and grabbed the a from that one. So then it would be over 2. So then I should be able to simplify it as, since 2 goes into everything, it should be then 1 plus or minus the square root of 5. So when I do my calculator, remember I should get, if I go 1 plus the square root of 5, I should get 3.267, which I do. And if I go 1 minus the square root of 5, then I get that negative 1.23. So these are zeros, would do approximately negative 1.236 and 3.236. But here's what you'll do for your zeros on this one, on your, especially on your homework. Oh, sorry. Thank you. On your homework, you're going to want to go ahead and list them. So my zeros will be then 1/2, and you're also going to have, you can usually, that usually takes the plus and minus, so it's plus or minus the square root of 5. I know that it should take it that way. I've plugged it in before like that, but I also know that some kids just go ahead and separate them out, and then they'll have 3. So any questions so far? All right, and because of the factorization theorem, what they're saying is if I have a 0, just like I did before when I did this problem, which was a little easier, I can write it in factored form. And it kind of, to me, this, when I look at this, it looks confusing. But what they're doing is they're taking all the zeros and they're just going x minus that number. So remember, when I had the factored form, when I had zeros of 1, 4, and -3, notice that I'm going to have x minus 1 and x minus 4 and then x plus 3. It's going to look like the opposite in the factored form. So if I'm given that I have like the zeros, if I know the degree and I have some of my zeros, I can actually find all of my, like my original equation. So with this one, it says find the nth degree of the polynomial function with the real coefficient satisfying the given conditions. So in other words, this is going to be my degree. And it's 3, so you know that it's going to be the highest power I'm going to have is x to the third. But then I'm also going to have a 0 of 6, and I have a 0 of 5, a -5 plus 2i. Now remember, when I have a degree of 3, I should have 3 roots, possible roots. So in this case, when I have a -5 plus 2i, I also will have -5 minus 2i, because when we did our quadratic equation, we always have that plus or minus in front of that radical, and that's how you got the I. So if I have one of them, and I know well, one of them is plus I know that there's going to also be a minus I as well. So when I write this, I know that I'm going to start off with, I could have a leading coefficient that's not 1. So I'm going to let that be A for a second, because then we're going to work on that in just a second. But then I'm going to have my factored form. If I have one of my zeros is 6, I know I have x minus 6. Right?
Yeah.
If I have another 0 that is -5 plus 2i, I will have x minus, and I'm going to go ahead and put it in parentheses of -5 plus 2i, because that's that's my root, but remember I have that minus in front of all of my roots. And we're going to take care of that in just a second. But I'll also know that I have an x minus, and then I have another root of -5 minus 2i. Do you see how I came up with those? So here are my 3 roots, right here, here, and here. And I put a minus in front of them, and I'm write it as x minus that root. Because I know that if they're giving me this one, then I will also have a -5 minus 2i from my quadratic equation. So remember, I have a minus b plus or minus the square root of b squared minus 4ac. So when they came up with all over 2a, okay, that's no, but because of the fact that they have an I here, I know right inside here, this was at some point 0 or negative a number, because they gave me a result of I. And if I have a positive 2i, I also know that I'm going to have a minus 2i. So if you're given one, you will automatically know there's another one because of what we know about the quadratic formula. Did that help? Okay, so that's how I came up with the 3. Now, this is what I'm going to tell you right up front. This, if you do your question help, they're not going to show you this, but it's a little simpler if you do it this way. I'm going to start with x minus 6. I'm going to distribute this in. So I have x. If I have a minus 5, I'm going to have plus 5, correct? Then I'm going to have a minus plus negative 2 or positive 2i, so I'm going to go minus 2i. Then I'm going to go over here and do the same thing. So I have x, I'm going to have plus 5, but this time I'm going to have plus 2i. Okay, I'm just distributing my negative. Now, what I like to do is you can, and the way the help does shows you, they take the x and they multiply it times every one of my terms. Then they multiply the 5 times every one of my terms. And then they multiply the negative 2 times every one of my 3 terms. But I like to look at it, I'm going to rearrange it just a little bit because I want you to look at it in the fact that I have x plus 5, okay, minus 2i, and I have an x plus 5 minus 2i. Because I have that situation, I really have an x, like an a minus b times an a plus b situation. And I know that if I multiply those out, that I take my square of my first one minus the square of my second one, and that'll save me just a little bit of time. You can still get it. What will happen is if you go ahead and expand it out like they do in the help, then you're going to be able to eliminate a lot of your middle constants, okay? So, yes, as I wrote it just with minus. Okay, so I'm going to go ahead, I'm going to end up with x plus 5 expression squared minus 2i expression squared. And it'll always work that way. I still have the a. I'm going to keep bringing everything down, okay? But now this is a lot easier to simplify because I know I can do x plus 5 expression squared in my head, kind of. Okay, so remember it's not x squared plus 25, right? X squared plus 10x, yes, plus 25. Remember it would be plus 5x, which is going to be my plus 10x. And then I know that on this one, I can go minus, then I've got 2 squared, which is going to be 4i squared. But what is, yeah, what is,
Which is,
yeah, this is going to change then to a -1, isn't it? So that's going to be -4 times a -1 is going to be a +4. So right here, I have x squared plus 10x. I'm going to have 25 plus 4. Or 29. Okay, so here's my equation so far, and I'm just going to keep this one right here because at this point, they also, on your help, expand out the 6, but you really don't have to at this point. I need to find out what A is, and I can actually use it in my factored form right here. Because if I know that f of 2 is going to equal -636, that means that right now it's f of x is equal to a times all of this. I can replace all of my x's with 2's at this point, and then I know it's going to equal a -636. So I'm going to do that. I'm going to go a minus 636 is going to be changing to f of x. A is still what we're looking for. So then I'm going to replace it. I'm going to have 2 minus 6 times, then I'm going to have 2 squared plus 10 times 2 plus 29. And then I'm going to simplify. So I'm going to end up being 2 squared, which is going to be 4. But, again, I'm going to go 2 squared plus 10 times 2, which is 20, plus 29. Okay, so I have 53. And then I have 2. I'm going to go ahead and go A is 2 minus 6 is a -4. And then times 53. So 53 times 4, or negative 4 is 212. So I have a negative 212 times A is equal to a negative 636. So now if I take 636, negative 636 divided by a negative, divided by 12, I know that I'm going to get a positive 3. Now, I didn't put my two negatives in there because I just went a negative divided by negative is going to be positive. That makes sense on what I did. So if I want my equation, then, and again, it takes it, I've checked it a couple of times, it will take it as a factored form. So you could write it as 3 times x minus 6 times x squared plus 10x plus 29. As long as you have all of these right, then it will take it. Now, I'm going to tell you right up front, if you get down and you get one wrong, and let's say you had a sign, take, and you found your error, and so like say we got all the way down to the end, you submitted it and it didn't take it, and it didn't take it, and it didn't take it, and it was off by one little decimal. Take a picture of your work and also the answer, and and tell me what you did wrong, and I will give you credit for it, because it is a lot to put it in, and as long as you understand how we're getting it, I will give you credit for your homework assignment, because it is a little bit tedious. Okay, and I think you have just one or two of those. Does that kind of make sense so far? Okay. Does that one, did I skip ahead? No, 3, 4. Now, Discardi's rules, Discardi came up with another little trick. And Discardi's rule of signs found out that, you know what, out of that list of the possible rational roots, like this is our page 1, remember we had quite a list right here. But Discardi's rule of signs tells us that we can kind of still eliminate some of our possibilities. And so what we find out is if we look at the signs, now finding the positive real zeros is pretty easy, because what I'm going to do is look for sign changes. So I don't change f of x at all, okay? I'm going to keep it the same, but all I'm going to do is write out the signs. Like for instance, 2 has a negative in front of it, so it goes from negative. The next one is going to be positive. The next one is going to be negative, and the next one was positive. And all I'm doing is looking at the signs in front of my leading coefficients. Does that make sense on how I got that? So if I look here, if I go from negative to positive, that's a change. Okay. So in this case, I'm going to say I'm going to put a star. I've got one change here, but look from here to here, I have another change. And then I have another change here. So I have 3 changes. So that tells me that I have either 3 or, and I reduce it by 2 each time, or 1 positive real roots. Okay. So in other words, I know that it just helps to eliminate some of them. If I can find one. Now, 3 is going to still takes me a little bit, but look at the f of x, of negative, for the negative. If you substitute negative x in for your equation for the negative, the possible negative roots, then I'm going to end up with 2 times, I have a negative x to the third plus negative x squared, and then I'm going to go minus x, and then plus 7. And then I'm going to simplify it a little bit. So if I have a negative, if I have x to the negative x to the third, that's negative, times a negative, that makes it positive, correct? Oh, it's still, I'm just worried about the sign in between. So that's why I didn't even, I really, I can, I'll put it in there because it's not going to change the fact that it's still going to be a positive number. Okay. I'm really worried about, is it positive or number, but I don't have to know what it is. And then the next one, if I square the negative here, that means I have a plus and a plus. So I have this one is a plus, isn't it? If I square x squared, negative x squared, I get a plus, positive, but I have a positive in front of it. On the next one, I have a minus and a minus. It's going to be positive. And then I have a positive 7. So I have 4 positive numbers. There's 0 changes, right? So that means that I have 0 negative roots. Okay, and so on this one, again, you always go down by 2. If I had 2, I would have either 2 or 0. You subtract 2 from each one. So in this case, but that would eliminate out of my factors over here. That tells me that I could eliminate all of my negatives. So let's go back to our Desmos real quick. So this one was x to the third. And remember, whoops, I do something wrong. Minus a -3, that was a positive. Did I have the right one? Oh, I have the wrong one listed. That's why. That's the wrong formula. Okay, so then let's go ahead and let me just put it in. I thought I did, but I didn't. So I had -2x to the third plus x squared minus x and then plus 7. And look at this. So this tells me I have 0. I have 1 real root, but I have 0 negative roots. It's not even a cross on the negative, and that came from Descartes. Okay, so Descartes kind of helps us eliminate, again, different possibilities as well. So back to my work. You're going to be asked to kind of utilize Descartes. So remember, for positive rational roots, you're going to keep it exactly the same and just write the signs and then look for changes. If I have the negative roots, then I'm going to substitute negative x into it. Then I'm going to look at the signs and look to see if I have any changes. So some of the ones that we've already done, we did a lot of work on this one right up here. Okay. If I were to apply Descartes, can you guys go back to page 2? Okay, remember I have two positive roots and I have one negative one, right? So Descartes would say if I look at f of x, okay, so I'm looking at my original function. The first one is, then it goes. Okay, so I had a change here. I have 1. It didn't change, but then I have a change here. So Descartes would have said I had 2 possible positive roots. And I actually had 2. Okay, I could also have 2, or I should say 0. In this case, I knew I had 2, but so I should have written 2 or 0 possible rational roots. Then let's go ahead, f of negative x. So I'm going to substitute it back in. It's still going to be a negative x to the third. I can do it in 2 steps on this one. Minus 2 times negative x squared minus 11 times a negative x plus 12. So the first one is going to be, then I have a negative x to the third. That's going to be a negative, correct? Then on the next one, I'm going to have a minus 2 times x squared. So it's still going to be a minus. The next one, I had a negative 11 times a negative x. That's going to make it a positive. And then the last one would be a positive. So if I have a change, I have one change here. So I have 1. And so if I go minus 2, it's a negative number. So I have 1 possible negative root. And that's what it ended up being. Okay. So Descartes just kind of helps us figure out that we can eliminate a few more of our possible roots than we had to begin with. All right. Again, I do not think using Desmos is wrong. So if you need to if you need to look at Desmos to plug in the answer. That kind of helps give you a little bit of where to start. You don't, but I give you one root. So instead, like what Desmos does would allow you to find one of the possible roots, and then you can substitute that back in. I'm not going to give you anything more that everything after I give it to you can be factored after that point. So after you use the 1, then you have a reduced polynomial that you can factor. Okay, even if it's the highest I go, There's a few x to the fourths that you can actually use pretty easily, because when you give that one root, then you have something with x squared that's like a difference of two squares, and then you can find the other two roots. But it's either that one or it's going to be then like an x to the third. So all of it, everything after I give you the one, you should be able to factor it easily. Does that make sense? Hopefully. I think once you get started in them, it'll make more sense too.